All right. Thanks a ton, Dave. I appreciate that. So, welcome to the webinar today. As Dave was saying, we've got two great presentations lined up. So let's go ahead and just jump right in here. All right, here's a short overview of what we're going to be doing today. I'm going to start off by introducing our two presenters, give you a little bit of the rules of the road for how we're going to handle this, and then I'm going to turn it over to Dave Andrews, who's going to be talking about a modeling project on a chemical facility, and then Chris Heliotis, who's been doing a project on a fertilizer plant. Both really fascinating projects with some really interesting and challenging workflows. And hopefully at the end of this, we'll have some time left over where you as the audience can ask questions and get some good feedback from these guys and pick their brains. So just real quick, the rules of the road here. We're going to keep everybody muted during the presentation. And as questions come up, please do feel free to ask them, type them into the chat window. And at the end of the session, we'll take all those questions and pose them to our presenters here. Now, they are going to be done on the first come, first served basis, and we don't always have time for all of the questions. So do go ahead and put your questions in as soon as you think of them. And that way you start filling up the queue, and hopefully we'll get to your questions sooner that way. This webinar is being recorded, and you'll each receive a link to the recording afterwards. So with that, let's get started here. And let me introduce Dave Andrews with Accurate Technologies. Dave, can you give us just a little bit of a sense of your background, please?
Yeah, I started in surveying in 1998. Followed that all the way through at a few different companies. Started work at Accurate Technologies in 2007. We bought our first scanner in 2009. I've kind of taken the reins on that. 3 years ago, we bought a laser tracker, actually two laser trackers, to do our high accuracy alignment work, and I've been working on that along with the scanning ever since.
Perfect. Thank you, Dave. Chris, with EndeavorRev, can you please give us a little bit of your background?
Sure, Kevin. I've been a surveyor since '99. Started with a large civil consulting firm. Got introduced to scanning pretty early. I got my hands on a SIRA back in 2000, so and a little gap thereafter before I really got into scanning, but I've been scanning for about full-time for about 13 years now. And I recently left the corporate world and joined into a small BIM firm and made it into a scan to BIM firm.
Perfect. I'm always impressed with and jealous of people who started scanning back in the SIRA days. That's awesome. My name is Kevin Williams. I'm the Chief Scientist at ClearEdge 3D, and probably the most pertinent part of my background is I love doing webinars where I'm not in the hot seat to present. So I'm going to leave it at that and turn it over to these guys. And let's start off. Dave, can you tell us about this project you did in St. Louis?
Yeah. First of all, good morning, everybody, wherever you are. I'm in Westlake, Ohio today. It's nice and cold and snowing. Nice stone's throw from Lake Erie. The facility that we worked on is in the St. Louis area. This facility is fairly old. It was built in the 30s. And this project scope that we have is to scan it, model the piping, so that the engineering company that we're doing work for can go ahead and create new P&ID sheets from the models. And we're doing some structural, basically anywhere a pipe would touch the structural or a hanger or anything within the facility. A little background on Accurate Technologies. It was founded in 1986 by Rich Carpenter. Rich was an employee of the Timken Company, and in the mid-'80s. They had a massive layoff. He did alignment of all the equipment, and when they laid him off, there was nobody else to do that. So he founded the company to continue that. And as of Monday, we're actually being acquired by R.E. Warner and Associates in Westlake. So our portfolio of what we're able to do as a company is going to grow immensely, and we're all really looking forward to that. In 2009, we bought our Ferro scanner. We've been steadily growing every year since then. We also pretty much do everything you can do in surveying. I don't know if there's anything available that can be done that we haven't done. Our bread and butter work is the high accuracy equipment alignment. Like I say, Rich has been doing that for 30 years, and with our laser trackers now, it's a whole lot of fun to go out and do some of this stuff. The chemical facility currently is producing additives for the oil and gas industry. There's some other things that they do, but I'm not privy to all the information of everything that comes out of there. The facility is old enough that they made Agent Orange there, so that was nice to know once we were there and already in the buildings that that kind of chemical was produced there. One of the issues that they have, the place is old enough that they have a lot of piping that they don't use. They don't demo it. As new piping goes in, they will just route around the existing piping. So that's all part of the project, is they're going through figuring all this stuff out so they know exactly what they have and they can clean up their facility. From the scanning and modeling side, they wanted every pipe from an inch up to 36 inches, the range that they have there. Some of the challenges that we actually ran into, the place had no plant control. At one time there was some survey control, but it had been demolished or paved over. So we used some drawings from the 1960s that showed coordinates on building corners. So we traversed through the facility, and everything worked out. It was just a 5-foot bust in those coordinates. So after some adjustments and some things, we were able to get started pretty quickly. Due to the size of the facility, we had to pull in 80 to 100 scans per day. So our guys were working 12 hours in the plant, constantly moving. We didn't really take much of a break during the day. One guy would take a lunch break, then the other guy would take a lunch break. So we really kept a good pace, and our field guys have done a fantastic job. One of the other challenges, the facility was running while we were doing it. So we would run into situations where we could not get work permits for hours on end, which only made the challenge of getting this thing done that much tougher. Because they never take things away, demolish piping, the place is really cramped, as you can see from the picture. In pipe racks you have pipe on top of pipe. This was pipe on top of pipe and then a ceiling on top of that. So there's areas that it was almost impossible to get scan data in. And one of our biggest challenges, quite frankly, was the client that we're doing the work for was new to scanning. So they did not have a good idea or a good feel for what scanning did. And their reply to me was, when I asked the question, what do you really want? It was, well, just get everything. So, that's fantastic, and we all think that we can do that, but the reality is we just could not get everything at this facility. So our field collection, we started everything with survey work. That's our bread and butter as a company. So we did a big traverse around the entire facility so that we could sit on 2 control points and start putting things in for each specific unit of the facility. And that took a little bit of time, but the way we approached it in the field, guys, they did fantastic. We use a Faro Focus 3D. It says 4, but it's actually a Faro. And that machine has done fantastic for us. We haven't had any hiccups with it, and it's done a real good job getting the data that we need. Part of the issues was we could only plan day to day. Sometimes they closed things down because they had H2S in an area, so we couldn't get in there. So when we walked in the front door of the place at 7 o'clock in the morning, we didn't know if we could do what our plan was or how things were going to change. And luckily, we haven't had any rain out there at this facility, so every day that we've been out there has been productive. And with the multiple levels of piping, we've had to do a lot of things to get our scanner in the position to catch it. So we've been on a lot of catwalks. We've done a lot of scanning from distances that we normally wouldn't do just because we could actually see some things that we couldn't from the ground. There's 9 units at the facility, and we looked at each unit as its own individual project. And then we also took that a step farther in some of them when we looked at each floor as its individual project. And we felt confident enough with our survey work that we could just let it do its job. And at the end of the day, I think we really did a good job with our survey work because we didn't have hardly any misalignment in piping. There was no elevation buffs. And the reason we took that approach is because there were stairwells at the ends of the units. And I've always just had a fear of going up a stairwell and then taking those scans out a couple hundred feet and making sure everything lines up floor to floor. To date, we've got just over 1,600 scans, and that is a lot, both on our network and just the volume of scans, and we were able to do that in 19 days. All of our fitting and everything has gone through Faro Scene. It's done a pretty good job for us as far as fitting and keeping everything moving along. The office workflow, well, that was a challenge. When we first started the project, the idea was we'd have guys at the facility for a week, and we would just simply next day SD cards back and forth. The facility found out we did that on the first day and said that's a no-no. So the office work came to a halt, and we could only do the office work when the crew came back from the facility after being out there for a week. So instead of having a day's worth of work, I'm going to have 7 days worth of work and have 600 to 800 scans that I would have to deal with on the spot and try to get everything organized. And that was a little difficult, but we managed it well, and everything's done, or everything has gone better than I had anticipated. We have 3 4 terabyte hard drives that everything is stored on. The project is actually 2 terabytes at the moment, and that's, to me, that's a big project. I hope some of you have a bigger project out there. At the moment, we have 2 to 4 people doing the modeling at any given time, and they're doing a great job of the modeling. And there are challenges that they have, shadowing, steam, all the things that the scanner does have become a challenge. And one of the biggest challenges when we started this was how are we going to organize everything? And we've developed field sheets for absolutely everything. So if we do anything in the field, the guys can make note of it, and that really makes the office time go faster and faster. And it makes the ease of never being on site to fitting all the scans and everything making sense. It really helped us out. So once we have all the scans fit together, we take all of them and give them to our client. They take what P&ID sheets are available along with the facility, and they go through Ferrocene and they label all the P&IDs for us. And as they're doing that, they're giving us back the scans. So then our guys are able to sit with Ferrocene open, seeing the tags for each individual pipe, and then they're able to look right at it in Edgewise, and we can take off and start tracking out the piping. Edgewise did a fantastic job from the start with the auto-generating of the piping. I figure we're getting 60 to 70% of the work done for us, which is remarkable because we were actually fairly new Edgewise users when we started this project. So it's done really well for us. The top features that our modeling guys like is the clear view because we can turn and look exactly how it looks in Ferrocene. We can see that exact same image. So it works out real well to identify things. The structural, we're not doing a ton of structural with it. We're making, I-beams that might be 6 to 8 inches long, just enough to show that this is where the pipe is touching or is supported. A final deliverable for us, when the client first came and approached us about the project, they wanted to do everything in SolidWorks. So I have no familiarity with SolidWorks at all. Did quite a bit of research on it. They found out that they couldn't do what they wanted to do with SolidWorks. So one of the reasons we got the job is I was able to find the quickest way to get it from Edgewise into SolidWorks, which was simply exporting everything out of Edgewise as a COE file, then importing it into AutoCAD, and then exporting each individual pipe to an SAT file by the P&ID name. The one challenge that we do have with that, and if anybody has a better idea, I'm all for hearing it, we can't pick a single run from Edgewise and export it. It seems like we have to export the entire project. So when we're doing that, we're exporting 13 or 14,000 pipes, and then that import into AutoCAD takes quite a while. But we're able to still be productive with Edgewise, and then it's just a simple, we can go in and click off the layers that we don't want to see in AutoCAD, and that helps with our exporting. I went back through and I tracked a couple of pipe, and I firmly believe we're saving 60% of how we would have done it with our old, the other softwares that we have. The Auto Connect and all the things that Edgewise does has really helped us out and has really saved us a ton of time with all the piping. And this project, I don't know if we would have gotten the project if we did not have Edgewise. So, for some tips and tricks, for me, it always goes back to survey work. I find it to be a lot easier to put, quite a bit of survey work out to do everything. It makes checking and what you're trying to make sure you have much, much easier. And we also use a combination of spheres and checker targets. What I like to do is set all my checkerboard targets to a specific elevation. And then as I'm going through using them, you pick it off in Ferrocene and it tells you what the elevation is right there. So That's something that I've learned along the way that just helps me out and is an easy check. The biggest complaint that we've had from our modelers is we don't have enough scans. And I don't know that we will ever have enough scans for a facility like this. I'm sure some of you have done this. It's just impossible to get your scanner everywhere you need it and to see every single thing that you need to see. And probably, you know, one of our bigger things has been the new client. Our new client has been a challenge. Getting over that hump with a new client, getting what they need and trying to meet their expectations and making sure that you know you're doing a good job and you're getting what they need. That's always a tough one. So that's what I have for you.
All right, thank you, Dave. Very good. Yeah, that's certainly an interesting project, and it's always a little bit of a challenge working with a client who doesn't understand as much about the technology as you do. And it's just an educational process. I'm sure most of you guys in the audience have come across that in various scenarios. Next up, we've got Chris Heliotis. Chris, can you tell us about your project?
I can. Good morning, everyone. Thanks for joining us. I'm joining you from lovely Portland, Oregon this morning, where it's shockingly sunny. Weird. But I am with a company called Endivarev. And do I have control, Kevin? There we go. Endivarev was founded by my business partner in 2014, and initially it was purely for Revit training. But as time went by, the clients started asking for, you know, a little bit of support here and there, and then started asking my partner just to do the work. So it rapidly grew into a Revit service provider. And we actually met while I was on a site walk with another firm. Started talking about it and decided we could take it in a new direction. So I quit the corporate life and I joined as a partner, and it's really expanded rapidly into a full-service scan-to-BIM firm at this point. Most of our clients are either electrical contractors, surveyors, architects, MEP contractors, but the client list just is expanding exponentially at this point. And we also do lighting analysis, and we do BIM coordination as well. Oops. Sorry, folks, got a little lag on my end here. Okay, so this project is a fertilizer production facility, and the primary goal was to add additional railway. There's 5 existing railways. They wanted to add 3 lines. There are 2 depots, one for offloading raw product and one for onloading sellable product in the form of phosphorus and ammonia as fertilizer. The accuracies were, you know, they were tight, but not real tight, about a ½ inch, which is a lot looser than what I'm used to. But because of the nature of this being a rail depot, it was really difficult to get surveyors on site in a safe fashion. So the exterior areas were surveyed via conventional methods with total station, RTK GPS, and the project surveyor decided to take a whack at using scanning for the interior rail areas just to keep people out of harm's way. It's a 24/7 operating facility, and just because of railway schedules and other factors, it was not shutdown just wasn't an option in this situation. So there was no time where they could get on site in a safe manner. They needed a lot of data. There's a lot of steel, platforms, stairways, piping structures that they needed to plan around for routing this railway. So the project surveyor went out, rented a Leica C10, and set a traverse basically. So they set the total station and actually backsided it and ran I guess a scanner traverse, if you will. Backsiding known control, foresiding forward control, and moving the scanner as they went. So they did 18 scans, but it took them a full 8 hours just because trains would roll in, trains would roll out. They'd have to wait for long periods of time. And, compared to a phase-based scanner, as you all know, the time of flight scans take significantly more time anyway. And they ran 2 independent traverses, one for the load in, one for the load out. So there's a north and south depot. And they did the preliminary registration of that data using Leica Cyclone 3. Once I received the data, I never really have faith in anybody else's registration, I guess. So I actually tore the data apart and I re-registered it in recap, just so I could have solid QC numbers that I was in control of. So this was kind of a different project for me in that I had no part in the scanning. The scanning was done prior to Endeavorev even being brought on board for this project. And the firm that was doing the scanning had done a little bit of scanning, not a lot. The client had 0 experience, so they decided it would be more efficient, cost-effective to pass it on to someone more experienced than they were. So the data sets were small enough that they could deliver them digitally in a relatively short period of time. And like I said, I took that registration, I looked at it, I decided to pull it apart, re-register it just for a warm fuzzy. Everything came out really well. But the one issue that we did have was that they were using a time of flight scanner with not a whole lot of setup, so there were significant shadows, areas that I just couldn't see. So in the 3D modeling portion, I had to be very careful and do some interpolation to get all the features out of it. And to this end, Edgewise did a fantastic job. It found the vast majority of the steel without much help from me. Piping was sort of a secondary issue. We weren't overly concerned unless that piping was in a position where it could possibly interfere or be hit by a locomotive. But the feature that I guess helped me out the most, which is a relatively newer feature, I've been using Edgewise for a number of years now, was the pattern extract. There was a ton of repetitive steel in this situation, so I could go in, find 2 pieces of steel, and do a pattern extract, and they would find runs of 6 or 7 at a time, which saved me just an immense amount of time of manually either modeling or downloading and placing steel. So for my modeling tool, I actually used McNeil Rhino. It does a really good job on the freeform sort of modeling, such as the rails, and just a lot of the features that aren't really a standard feature. But the model deliverable had to be in CAD, so I had to create things in such a way that AutoCAD would read them correctly. I used a lot of intermediate softwares to do this, but in the end it worked out really well. We also created a Navisworks model just so the client could fly through the point cloud and fly through the model. I calculated that if I had to physically model this steel or import it and fit it and manually place it, it was going to take me about 100 hours to complete this project. I did it in 40, which also translates to a 60% time savings. So once again, Edgewise saved the day for me. As I said, I used a wide variety of software. A lot of it just very specific to point cloud manipulation or modification of solid objects, which is pretty standard on every project. I think I go through generally 5 or 6 pieces of software on any given project to get to the end result. But Edgewise was just critical for extracting that structural steel, and then using Rhino for all the other appurtenances just made it really easy. And that's it.
All right. Very cool. Thank you, Chris. That's fantastic. That was really kind of interesting geometry and everything like that in that project. That's fantastic. I've heard a lot of good things from Rhino from a number of people. All right. Well, we've got a bunch of questions already. If you, I'm going to start going through these questions. If you guys think of more as our presenters start answering these questions, please feel free to type them in. And let's get started here. So Dave, the first question for you. You said that the plant was still running, it was still operational as you were scanning it. Did you have any problems with vibration?
Yeah, we did. There are some catwalks that were vibrating. What we tried to do was obviously avoid those areas, but there were a few times that we just weighted the tripod down to try to minimize the vibration. And it actually didn't turn out that bad. I was kind of fearful of how it would look, but we did a good job of handling that vibration. But yeah, it was definitely there.
Okay. I'm curious about the same question. This is particularly directed at you, but Chris, with the train station there, did you have any problems with vibration from that end?
I actually wasn't on site, Kevin, but I think
Oh,
they did a pretty good job of scanning from protected positions. They never really got in between the rails or anything like that. And I didn't see any evidence of shimmer or anything like that in scan data.
okay, that makes sense. I assume you can time your scans as well. Uh, Dave, how many crews were you actually using on site?
We actually only had one crew on site. The two gentlemen that were out there, Rick McDonald was our lead guy on site. Rick's been a surveyor for 30 years. He does a fantastic job. Our second guy on the crew, we rotated some fellows in and out, but we actually only had two guys on site the entire time.
Okay. And one more question for you, Dave. What resolution and quality settings did you use with your scanner?
For the most part, when we were inside the buildings, we used the fifth 1 to 5 setting on the Faro with a 3 quality, which provided some very good speeds for getting the scans done. It felt like it took longer to do the pictures than it did anything else.
Okay. Uh, Both of you guys, how were you able to capture the high piping? So it looks like there's quite a bit of stuff that's higher up here in both of these scenarios.
This is Dave. For us, whenever we had high piping, we would turn the resolution up on the scanner. If we couldn't actually physically get close enough to get what we thought was the good data, we would get ourselves in a good position, turn the resolution up, and let it sit there maybe from a quarter scan. I think we did just a couple of half scans just trying to get enough data on the piping.
Okay. And Chris, I know you didn't actually take the data in this particular project, but you have plenty of experience doing so. Do you have any recommendations for capturing higher objects, higher piping?
Yeah, I think in this case, the surveyors made a good choice. I'm a big proponent of phase-based scanning just for speed, but for distance shots, it's kind of hard to beat a time-of-flight scanner. Nothing in this data was even close to out of range for the C10. So, I think if you really have to hit high structures, the time-of-flight scanner might be the way to go.
Okay, great point. Again, this question is relatively generic for both of you. Uh, you both had significant time savings. How did you calculate those time savings values for using automation? And Dave, why don't you answer that first?
Yeah, so what I did was I took a few of the pipe runs, some of the longer ones, and I went back and used some of our other software and just timed myself on how long it would take me to do it, how that software performed, and then I asked one of our guys to go through and figure out the exact same thing. So we probably had half a dozen that we figured out, how much faster our modeler was than the way I was going about it. So, we were all over 60%. Some of them were less, some of them were more, but 60 seemed to be the number that was right on.
Okay. How about you, Chris?
I actually have a steel library that I've created over time, and I sort of took a test section run where I had to manually place the steel and align it to the point cloud, and just sort of interpolated that back to how long it was taking me when I was doing pattern extractions, and it came out to around 60%. I could place the steel pretty fast, but then I'd have to wiggle it into place all the time, which can get time consuming.
Right, makes sense. Okay. Um, here's actually a question for me. Somebody's asking about getting a step export from Edgewise, and that actually is coming. Hopefully somewhat soon, sometime in the next quarter or two, is when it's scheduled in our roadmap. So maybe by summertime, we should be able to export to step format, which I think will be a very helpful thing for a lot of people. Had a lot of people ask for that. Chris, let me ask you the next question. Did you consider any of the hand scanners? I'm sorry, Dave. This is to Dave. Um, did you consider any of the hand scanners to fill in any of the gaps? And with when would you consider doing something like that?
Yeah, we actually did have Faro bring in their hand scanner. We never put it to use. We have thought about it in some of these areas. The only thing that we would really have to put it in use for is when we have a situation where we have a ceiling and then a row of pipe hanging off the ceiling and then the row of pipe that's hanging right below that. So you don't even have but 2 inches between the pipe layers.
Wow.
At that point, all we're doing then is using what we can see, and then we count what pipe is in there, and then we just move the pipe over and we try to pick those runs up where they come off of that ceiling. But we did absolutely bring in Faro to see what that thing the hand scanner could provide for us. We just haven't put it to use, and that's not to say on a return trip we may not do that.
Okay, fair enough. I know there's definitely some interest out there in that type of technology. Um, let me ask both of you guys this question. Real world piping is rarely parallel, perpendicular, and overall fabricated installed to even angles. For us, this creates issues when importing our model into Plant 3D. How do you handle issues such as this where Edgewise automatic processing can push you out of your project required tolerances? Or has this not been an issue for your client? Thank you. Chris, you want to
This is
address
Dave.
that? Go ahead, Dave.
For this project, for our client, the tolerances of the pipe wasn't a high priority. We did have a little bit of wiggle room with stuff like that. So being out of tolerance for them was not critical. The length of the pipe and where elbows were located, that was really more critical than being out of tolerance or having a pipe that runs on a 15-degree angle, because like I said, this place was built in the 30s and there's piping everywhere, and there's absolutely no rhyme or reason for it. It just goes everywhere.
Right. Chris, did you want to weigh in on that?
Yeah. I've run into that in the past. Like Dave said, a lot of times it's not so much of an issue. When it is an issue, I generally use the Edgewise piping as a guideline along with the point cloud itself. And one of the reasons I started using Rhino is I'll place the Edgewise pipe and the point cloud in place so that I know where all the piping is, and then I'll actually build a spline-based extruded pipe um, from the point cloud and then delete the Edgewise pipe. But it really helps to know where to even look in the first place.
Okay. And I'll address a portion of that. So natively, I know it's very difficult to make an 89 or 91 degree elbow inside of a lot of these applications, but particularly for Plant 3D, Revit applications like that, we've worked pretty hard to enable those applications to accept a more as-built representation of what's there. You can never get perfectly as-built, but you can now actually create those odd angle types of connections, and it comes across and it's much more as-built than it would be otherwise, and still a functional model. So just really kind of depends on what the customer is asking for and expecting. So you have to suss that out at the beginning of your project. All right. Next question is, um, eh, did you find that point cloud management in Recap eliminated many points? And if so, how did you deal with this? Was it enough data for Edgewise to work?
Um, I'll take that. Yeah, well, there's a default setting in Recap that a lot of people don't realize. Um, on import, it does an automatic 5 millimeter decimation. You need to turn that back down to 0 on import, and you won't lose the data that way. I don't generally do it, and I almost never have a problem when I get into Edgewise, to be honest.
Okay, perfect. I think that's probably very helpful information for somebody who's new to Recap. Uh, Chris, for the fertilizer plant, what did you use to create the ground surface?
Initially, we talked about this the other day, I did use the ground surface extractor from Edgewise, and I hadn't really had a lot of reason to use it before, and it did a really great job. So I brought that in as my basis for a mesh. Then I took a survey QC, and then I used some solid objects as break lines and extracted a gridded surface from that in Rhino.
Okay, cool. Um, here's another one for me. The question was, how does the software perform with point clouds generated with drone photogrammetry data? I assume that's Edgewise. We're actually going to be working with some of the photogrammetry software applications, hopefully in the not too distant future, to enable import of those point clouds and automated processing, but that does not work yet. So unfortunately, that's a TBD off a little bit into the future. Next question I have here is, how much overlap did you allow for between scan setups? And this is going to be primarily directed at Dave.
For this place, we just tried to fit as many scans as we possibly could in every area. The more overlap we could get, the better. To plan out what you wanted to do with this, as far as how much overlap you wanted, would have been really tough. So we just took the approach of, we're going to put enough scans in here regardless of overlap that hopefully we're picking everything up. And my guys did a fantastic job of picking up as much data as they possibly could.
Cool. Dave, this question is for you as well. What was the extent of the area that you scanned? Do you have an approximate square footage?
each unit, I went back and looked at this, the units combined, I believe were 68,000 square feet. And then every single unit had multiple floors. So while they were not all, the second floor wasn't always as big as the first floor, every single unit had between 2 and 5 floors in it. And some were even on, the one building had process piping on the roof, so it was actually a 6th floor.
Okay. And here's a question to clarify one or two of the images you used, Dave. The question is, why do the spheres appear to be green in the black and white scans? Scans that I do show them in shades of black and white, which makes it a little challenging to point them out. Can you just explain how those images were formed?
Yeah, so the black and white images were just taken right out of Ferrocene. So I didn't really take the care to turn off the spheres. So that is actually why it's green, is because that's the color Ferrocene chooses when it puts a sphere in place. So that's just a Ferrocene thing.
Okay. Okay. Perfect. Yeah, I think that'll help someone there. Um, here's a great question that everybody's always curious about, and I'd like to get an answer from both of you guys. Chris, I'll let you go first. How did you do on the job financially? And did you have to bid on the job? Can you tell us a little bit about the business side? And obviously keep stuff confidential stuff confidential, but can you give us a general sense for this?
Yeah, I came in $75 under budget, um, which was good
Nice.
because it was a pretty tight budget. And no, I didn't bid on the job. It, like a lot of our work, a lot of it comes from previous clients, previous relationships. This was purely a phone call and and a bit of a wag at a number because there was no defined deliverable. It was sort of asked of me that I could come up with a deliverable. So I sat down, I penciled out a workflow that I thought would work, gave him a number, and came in just under. Had I bid on the job, I probably would have bid about 30 or 40% higher, but just because it was an existing relationship, I thought I'd help these guys out, and it worked out fine for both of us.
Cool, cool. Dave?
Yeah, with ours, that's a work in progress. When we initially developed the scope of work for our client, they had really no idea what they needed from us. They, like I said, their idea was, well, we just need everything. So we developed the scope and we told them what we were going to do and deliver. And with them being new to scanning, they were wide-eyed and bushy-tailed when we started giving them things. So they started asking for more and more and more. So they've been gracious to us. They've paid us for some extras. There's a lot of things that we have been delayed on that has been an issue for them internally. So realistically, I think we're 40% over what we had budgeted to do the project, but our client has been impressed with what we've done, so they've been more than happy to write us some extras for the things that we're doing and keep our project from being in the red.
Excellent. It sounds like it's very important to keep good communications with the customer in a scenario like that. That's great. Here's one. Dave, you did more pipe modeling on your project. Um, do you and this is, I'm going to be curious about your answer here because we put a lot of work recently into the software to help with this. Did you feel it took a lot of time to delete objects from the automated model? I know that some of the earlier releases of the software, Edgewise, I think here would have a lot of false positives. and the person here ended up spending many hours trying to get rid of those false positives. How did it go on this project for you?
Well, it did a good job. The one problem that we've come into is everything out there has a radius. We've got corrugated steel roofs, handrails, so everything. I mean, we have a ton of piping. How we've dealt with it, we actually deal with it on the AutoCAD side. When we import it to AutoCAD, everything that we really truly want with a P&ID, we label that layer in Edgewise, and we put that pipe on that layer. So when we bring that stuff into AutoCAD, all the pipe we don't want to see is on the zero layer. So we're able to just freeze the zero layer, and then we can turn on each pipe that we want to export one at a time. But it did do a pretty good job compared to the first few projects we had with it, where we got piping on flat surfaces on the ground that had a little bit of gravel on it. So compared to the first time we've used it to now, we're getting a lot less of the false positives that are, actually on a flat surface or a corner. So it has improved, I feel.
Awesome. That's good to hear. Dave, did you use only spheres and targets for registration and scene?
Yeah, so our approach to it was, we based everything with spheres and targets and the survey work. What I would do then is go back and double check things with the cloud-to-cloud registration, just to make sure I didn't have any kind of errors that, sometimes you get a scan that's turned or doesn't want to fit for whatever reason. So I tried to use the cloud-to-cloud to double check myself and make sure I had a good fit.
Okay, and one more question for you. How did you make the second project manageable? Did you have to split the cloud and recombine later? Because you talked about having two different sets of points there.
Yeah, so the first unit that we did was 5 floors, and the lady that was modeling for us and was our lead for the modeling, she didn't want to deal with the entire thing. So we split everything out, and then she was able to go floor by floor, do all the modeling, and then she brought everything together in AutoCAD piece by piece. So it was a little difficult for our client to handle at first. Once they got a better idea on it, then they kind of knew what we were driving towards, and it seemed to work out okay for them. But yeah, so each floor we did kind of independently in Edgewise, and so far it seems to have worked out pretty good.
Okay. Did either of you guys thin the point cloud data in any way?
This is Chris. I did not, because the data was not overwhelming. There are circumstances, especially doing something like Dave's doing, where I may do a distance clip just to kind of reduce the data set size.
The only time we really did that was when we were outside, and we could define our specific unit. We would go ahead and clip off some of the data that fell, 100 feet outside of where we were working. But for the most part, 99% of the data we collected in the field went right into Edgewise.
Okay. Here's an interesting question. If you don't have a Faro camera budget, what camera do you suggest a small company can use with their scanner?
That is an interesting question, and I don't have an answer for it. I know from past experience, you can, with, obviously it's a Faro, but you can go in and apply pictures that you've taken from a point and shoot. At least that's how it was explained to me. I've never specifically done that. but one of the gentlemen from Faro told me that it's a very easy process, and I don't remember why I was asking that question, but yeah, I really don't have a good answer for that one.
I also don't really have an answer for that one. I have actually, I played with it in a piece of software that I was demoing a while back, but it was purely for my own education. I've never tried to do it. I mean, I'm sure you could get a Faro, whatever their new short range scanner, their 130, I guess, and overlay it. But I think you'd have to have a particular piece of software to pull it off. And like I said, I've never really tried it for a project.
Okay. Okay. So I've got a question on a recent answer here. So we can convert our drone photogrammetry data into most scan formats to simulate laser scanned data, PTS, RCS formats, etc. Is the reason for this not working in Edgewise due to formats or due to the data structure quality? And the answer for that is the actual data structure underneath. So within Edgewise, for a lot of the automated routines, we take advantage of the line of sight of the scanner. And to do those calculations, you need to know where the scanner was located. And a lot of the file formats strip that off by default, and that's unrecoverable afterwards. So RCS actually does have that inside, but that's a proprietary Autodesk format. But file formats like PTS, LAS, a lot of those generic file formats lose that information. So unfortunately, it's not recoverable. That said, a lot of all of the photogrammetry based software applications out there internally have that data when they compute their point clouds. And so it's just a matter of working with the manufacturers of the software to extract that information. So we're starting to do that now with some of the different manufacturers. All right. One more interesting question. What is spline-based extruder for piping? I believe, Chris, I believe you were talking about using that within Rhino. Can you explain that?
Yeah, it's a pretty simple process. You basically create a spline down the center line of the pipe from two views in Rhino, and then there's a command that will build a pipe on that spline that's actually a freeform pipe. So it's as simple as I would hold the edgewise fitting connection points, run a spline in top view, run a spline in a side view, and say create a new spline from those two views, and then hit the pipe command, click the pipe, give it a radius, and it creates it.
Okay, perfect. That sounds good. It looks like we've run over time. We still have a handful of questions we didn't get to. But I think just in order to respect everyone's time, we're going to call it a day. Thank you everyone for attending the webinar. Thanks a ton for both of our presenters for these really interesting case studies. It's been a real learning experience for me. I appreciate it. Thanks a lot, guys, and we'll see you at the next webinar.